My name is Susanne Ahmari. I'm a 2018 One Mind Rising Star Awardee, and I'm currently an associate professor at the University of Pittsburgh, as well as program director at Welcome Leap. And it is my distinct pleasure to be here introducing Maryam Shanechi here today in order to talk about her work as a new One Mind Rising Star. Hi, Maryam. Can you introduce yourself?
Sure. So my name is Maryam Shanechi. I'm associate professor in electrical and computer engineering, neuroscience, and biomedical engineering at the University of Southern California. And as you mentioned, I'm one of the awardees this year.
So first, I would love it if you could tell everyone a bit about your background and how you decided that you wanted to pursue science in general.
Yeah, that's a great question. So I started actually doing engineering, purely engineering. So did my undergrad in engineering science and electrical option, and then I went to MIT to work on a very theoretical topic, which is information theory, and it deals with encoding and decoding messages for wireless communication. So I was doing that, did multiple internships, but what I really missed was having that direct impact on people's lives, and I just was something that I was looking for. So when I was 3 years into my PhD, I started thinking about, can I do something else? Can I apply the same mathematical concepts to a topic that allows me to have that direct impact? And that's when I read about neuroscience, and the rest is history. So that's how I got fascinated by the brain. I wanted to use my tools to hopefully understand the brain and help people with brain disorders.
Well, this brings us to your One Mind Rising Star Award. So it would be fantastic if you could just give us a brief description of your Rising Star Award and what you plan to do.
Yeah. So as you mentioned, one of the challenges in neuropsychiatric disorders are this intra-individual variability. So what I'm hoping to do is to bring a machine learning and control theory as tools to identify personalized neural biomarkers of these conditions, such that we can have objective measures to track a patient's symptom state over time. And then that would allow us to precisely tailor our therapies to their needs. For example, deliver the therapy when and as needed rather than all the time. Now, this becomes especially critical in the context of deep brain stimulation, which is one application of what we do, because there we have access to intracranial activity. We can establish these personalized biomarkers and then precisely tailor the DBS or deep brain stimulation therapy to these patients' needs.
That's such important cutting edge work. So I'm really, really excited to see the outcome of your work.
Thank you.
So one of the things you mentioned, actually, this idea of tailoring to the patient's symptoms, I think is really important. And I'm curious, and it also raises a challenge, right? Because we have patients on the one hand who are reporting to us the suffering that they have in their lives, right? So they are struggling with symptoms like depression, one of the things that you're working on. But the recordings that you are making in the brain aren't necessarily linked to the symptoms that the patients themselves are experiencing. So I'm curious how you're bridging that gap within your own research.
That's a fantastic question. And that's actually the major challenge that we formulate in developing these mathematical techniques, that the signals that we record from the brain don't just relate to the symptom state. They relate to a lot of things that the brain is doing, whether we're talking or moving or experiencing other things. So the techniques that we actually develop try to dissociate those dynamics and changes in brain activity patterns that are actually symptom relevant by both using the neural activity to model, but also using labels of what the symptoms are over time as guidance to try to identify those relevant patterns and dissociate them from irrelevant patterns. So that's actually one of the major directions in the proposal that I wrote, how we want to actually achieve that mathematically.
Excellent. How do you work with patients and partner with them as part of the research team? Because I can imagine, particularly for your experiments, that's an extremely important thing to do.
Yeah.
You're getting the recordings from their brains, but you also need them as research partners in order to give you this access to their inner experience and the richness of the emotional experiences that they're having.
Yeah. So one thing I've started doing over the past few months is actually take the questionnaires that we give them myself. So I have this random app that gives me random reminders every day at different times to actually fill the questionnaires on the iPad app that we have myself. So that I can actually relate to what we ask them to actually go through. Of course, I cannot look at my own brain activity, but at the very least, I can experience what they do when they fill these questionnaires. So I think that's one way that we try to understand the kinds of questions and symptoms that we're trying to measure from them.
What kinds of insight has that experience given you?
So the fact that some of these questionnaires perhaps are not ideal for tracking day-to-day changes, some are more static and some are more dynamic. And depending on what we actually want to find a biomarker for, some questionnaires are more relevant than the others in terms of their time scale of dynamics and change. So I think that was the biggest insight that I got from filling these myself.
That's very cool, because most people do not take that step, I think, in order to really put themselves in the shoes of the person who's going through the research protocol. And we hear this time and time again that there's a huge burden on participants to actually complete these rigorous studies, and that it becomes fatiguing. And I applaud you for actually putting yourself through the paces and doing that.
And we try to make these quite easy to use, make them iPad questionnaires, making sure they don't take a few minutes at a time. So we also test that and make sure that they're not too much of a burden.
Great. And could you explain a little bit more the closed loop paradigms that you're using? So for a general audience, what's the concept there? What's the idea?
So when we say closed loop, we mean that we have some sort of feedback about how the patient responded to the therapy, such that based on what their response is, we can adjust and tailor the therapy to their needs. So in an open loop approach, you would just give a therapy, whether it's deep brain stimulation or a drug, you would just give it in regular doses. You don't adjust it over time. But when you close the loop, you actually look at, okay, how did the brain respond to this therapy? How is the symptom changing in response to this therapy? So that's what we mean by closing the loop, getting that feedback. Now, in our case, we get it in the form of brain activity and then decoding their symptom state. And then based on how the symptom state is changing over time in response to therapy, we then adjust it over time. So that's what we mean by closing the loop. It's kind of a feedback control system coming from the engineering concepts. That's how we control airplanes with autopilots, for example, or thermostats or all of that. But we're bringing some of those concepts and principles to bear in coming up with more effective therapies for patients.
So why do you think that's going to be more effective, and how do you think it will help patients?
So that immediately helps address the inter-individual and intra-individual variability, because when you have feedback, you actually know how things are changing over time. So you can adjust and adapt to that inter and intra-individual variability. So I think in terms of developing kind of precision medicine techniques and approaches, this could be one key element that can help.
Do you think it'll help to cut down on side effects?
Yeah, absolutely. So if you can give less therapy, whether it's stimulation or drug, then you, of course, will have less side effects. The other problem in some of these therapies is brain adaptation. So for example, for deep brain stimulation, it is known that if you give it for a while, the brain adapts, maybe the effect doesn't last for that long. So if you can, so it's more fundamental even than that. It may be that the response to the therapy changes over time because of plasticity. So you want to keep track of this by monitoring the patient, their symptom, how their activity responds, such that you can have more precisely tailored and effective therapies.
It's an important point.
Yeah.
And I think too, when I think about this with some of the people I'm working with who have OCD, which is my particular area of expertise, the brain state that they have when they're in an episode of OCD, when they're in a particular cycle of obsessions and compulsions, is very different from the brain state that they have when they're not experiencing an OCD episode. And I can imagine, and some of the things we're testing in our lab, is whether or not we can intervene particularly at those points in time when the person is in that brain state, during which they're going to need something very different to reset versus when they're going along just fine.
Absolutely. I think in OCD it's even clearer than, say, in major depression, because as you say, they have these episodes and then in between they don't have it. So I think these kind of closed loop approaches will be quite beneficial, especially in OCD.
Yep. So what advice would you like to give to young girls who are interested in pursuing a career in mathematics, engineering, or any kind of science?
Well, I would tell them to persist, that they're as good as anybody else to do it, that there will be challenges and bumps along the road, but if they try and stick with it, they'll succeed. And that's the key to a successful career, but they're just as good as anybody else to do it.
Excellent. And what gives you hope for the future of mental health research?
So what gives me hope is the fact that there are people from so many disciplines coming together, whether it's engineers, psychiatrists, neurosurgeons, neuroscientists, coming together to tackle these very complex challenges that, frankly, no one discipline on its own can tackle. So I think that spirit of interdisciplinary collaboration, working together to come up with better therapies, is what gives me hope. And I hope to build on this collaboration and extend them. And hopefully we can make a difference in these people's lives.
Wonderful. Well, with that, thank you very much to Maryam Shanechi for the wonderful work that you're doing. And thank you to One Mind for your support for this research.
Thank you very much.